Jeff Lendermon with GoEngineer. I'm an elite applications engineer and the senior plastic specialist within GoEngineer. I concentrate on the SOLIDWORKS Plastics simulation package and anything to do with injection molding and plastics, so mold tools and all of those things as well. I'm also a certified SOLIDWORKS expert. My background, I've been in the injection molding industry just about all of my career, which is more than 30 years. So in this 30-minute webinar, we'll be looking at the return on investment in SOLIDWORKS Plastics. I'm going to concentrate on plastics standard mostly in this. I'll also cover some of the topics that we can utilize in plastics professional and premium. What we're going to look at is SOLIDWORKS Plastics and how it can benefit the part designer. I'll show an example of a part error on a molded part, and we'll look at that, and we'll examine that part design and discover the cost of change. And we'll also break down the return on investment for SOLIDWORKS Plastics Standard based on this error that we find in a part and that design change. So SOLIDWORKS Plastics is our injection molding flow simulation add-in for the SOLIDWORKS CAD package. It simulates the flow of plastic melt into the mold cavity and provides results that will help part designers, mold designers, and injection molding manufacturers validate and optimize their products. So SOLIDWORKS Plastics will run in the SOLIDWORKS interface, and it streamlines our workflow to make any design change on the fly. So when we're looking at a plastic part design, the earlier in the product design process that we utilize the simulation package, our cost of change is going to be a whole lot less. So if we look at this graph, we're showing during the part design phase, our cost of change is low. During the mold design, it goes up. During mold manufacturing, it goes up more. Then once you get into part production or even product launch, that cost of change gets just exponentially higher as we're going along. So SOLIDWORKS Plastics comes in 3 different packages. It was developed to help our users predict and avoid manufacturing defects during the earliest stages of part and mold design. This will eliminate costly mold rework and improve our part quality and decrease our time to market. So Plastics Standard was developed more towards your plastic part designers. So it's going to answer our basic questions. Will my part fill? Where are there weld lines? And where will there be air traps? We can work with multiple gate locations in Plastics Standard, but it only works on a single body part. So if you wanted to start doing additional cavities or things like that, that's when we work into Plastics Professional. So Plastics Professional has more advantages for mold designers and mold makers. It goes deeper into the injection molding process, it'll add the packing phase as well on the process. So Standard does the fill, Professional does fill and pack. So Professional will allow us to analyze multiple cavity molds. So this case that I'm going to look at today is a 2-cavity mold. So I'll point out some advantages we have of running Plastics Professional. It's got a really powerful runner balancing tool that I really like. So it will balance your runner systems between multiple parts that are not identical. It'll help runner balancing in that. If you design plastic parts that have inserts or overmolding, Plastics Professional will cover that. It will handle hot runner systems with valve gating. It's got a valve gate timing sequence in there. It'll actually print out a little report for you that tell you when to open the valve gates. The fiber analysis is included in Plastics Professional. It shows you your fiber orientation. Another function that I like in Plastics Professional a lot is the part mass versus time plot. This is almost like doing a short shot study out at the machine. So your part mass versus time plot is going to show you at what point during the cycle that your part quits gaining any mass. So that's at what point does your gate freeze off and you're not able to push any more material into the part. Very handy. I really like to use that in Plastics Professional. It also covers reaction injection moldings or for thermoset materials. And then finally, plastics premium. So this is the top level of SOLIDWORKS Plastics, and it includes the advanced cooling analysis and the warpage analysis. Companies that do in-house molding, so you go through the full process of part design, mold design, and injection molding. Plastics Premium is geared toward that type of business. It's for the processor. We have the capability to analyze our mold cooling channels and part warpage as well. The project that I picked to look at the return on investment on a product, this tool, is a 2-cavity standalone mold with slides and lifters manufactured out of H13 steel. If the mold were to be built in China, the estimated cost is right around $16,000 US. If you're looking at building it in the US, it's somewhere near $27,000. I'll jump over into SOLIDWORKS now, and we'll look at the part and some of the interface. So when you jump into SOLIDWORKS Plastics is an add-in that's inside of SOLIDWORKS. So when we go into SOLIDWORKS add-ins, we can turn it on just like SOLIDWORKS Simulation or any of the other add-ins. Once you start it up, there's a tab, so you have your control panel tab at the top, and we also have this Plastics Manager tab on our feature tree on the left. This is where I generally run all of my simulations from the feature tree on the left. In SOLIDWORKS 2020, they changed the workflow for SOLIDWORKS Plastics, so I actually am running this in SOLIDWORKS 2020, Service Pack 1 right now. And when we start a new study, it works similar to the simulation packages that are included in SOLIDWORKS now too. So you start a new study, they're trying to make the workflow similar to that. I'll go through the basic setup of this model, talk about some things as we go through. Once you have your part set up, you start by defining your domains. So our domains are the completed bezel molded. It's set as a cavity. If I had a multi-body part, we will see that you have additional domains. If you had a family mold, you may have 2 cavities. If you have inserts, you can have the cavity and inserts as well. So in this case right now, we only have the molded cavity. I've got cooling channels set up, but I had chose to leave them out of this study. I can actually right click on them and tell them that I don't want to include them in this analysis. So it's really nice. You can go in and set them up and then run without it to start with. After we set our domains, the next thing we set are boundary conditions. So there's several different boundary conditions you can set. Injection location, clamp force are good ones. The symmetry face I'll talk about in this webinar as well. Air vents, filled hot runner system, and your coolant inputs. So when you add your water lines, you can actually put your coolant inputs in during the boundary condition definition. After that, then we go in and mesh our model. So this one I've already meshed. I'll just click on the mesh model up here, and we can see there's areas that I've actually refined the mesh around some of the radiuses and things like that on my model. The SOLIDWORKS Plastics package, I think, has one of the more robust meshing packages in there. You have a whole lot more control over where you add refinements. You can get a good curvature-based mesh. And there's also a hybrid meshing that I use where it actually extrudes layers of mesh on the outer surfaces and then infills them inside with tetrahedral mesh. So to get accurate results out of plastics, it looks for 5 mesh elements across the thickness of our part. And the hybrid meshing allows for that, and so it solves for 5 elements of thickness all through the part, even on thinner wall sections. After you've set your meshing, then you can come in and set your polymer. As I said, the database right now has over 4,000 different materials, ABSs and all of that. There's a convenient search bar, and you can actually have a user-defined database. So if your material is not in the default database, you can actually acquire all the information and viscosity, PVT curves, all of that from the material manufacturer, and you can input the materials yourselves. So the polymer material parameters, This top portion of this is important. This information is actually coming from the material manufacturer. So it's your minimum, maximum melt temperatures and mold temperatures, eject temperatures, and transition temperatures. So these are actually used during the simulation. And those temperature settings are actually in our process parameters. If I were to go to my fill settings, those temperature settings come up in my process parameters. So if I'm a part designer and I don't really know anything about the injection molding process and I don't know what settings I have, I don't really have to set anything. I don't have to set any of the fill settings or pack settings to run a simulation on this part. All I have to do is go in, mesh my model, pick my polymer, set my injection location, and then I'm ready to run. So in this case, we can come in and run flow and pack, or I can just simply run flow. If you're plastic standard, you will only have the flow option. With premium, you have flow, pack, and warp. If I were to have cooling lines, I would actually have the cooling analysis available here. So let's go in and look at the flow results on this model, and we're going to concentrate on looking at a couple of different items in here. So fill time is always an important one. This is also where you can actually look at areas and watch the filling of the material, the animation going through the part. So it's got this ISO surface mode with a solid mesh going on. You can actually see the materials flowing through the part and around certain areas, and how it fills in different areas, where the last places to fill, and all of that is. So I want to concentrate on the sink marks on this part right now. So if I switch over to sink marks, we can see there's a couple of areas of sink marks on this part. This is a door handle bezel. We would see the two areas where these sink marks are showing up. That's a visual area, so it would be a visual defect on this part. And we can see that the sink in that area is 0.127 millimeters, so that's about 5/1000ths of an inch. Some other things that we can look at while I'm in the results, we can look at the weld lines on our part, so you can see where the flow front meets around a certain area. If I were to go turn on the weld lines and go back to my flow front, I can back off the time and you can kind of see where that flow front comes together and where those weld lines are. So we saw the defect on our part. So the defect that I want to correct, this is my sink mark. Happens because the tabs on the bottom don't have enough draft, and there was a really large radius on the bottom of this face. So kind of some poor part design, but this SOLIDWORKS simulation package would pick this up. So this visual defect would really not be acceptable. So some things we could try to do to correct this would be increase our packing pressure and holding time. That's something we can also simulate, or that can be done at the machine. But that's going to lead to a longer cycle time, and it's also going to lead to inconsistent quality from batch to batch. If you're trying to process this out, you're definitely going to have trouble with it every time you run this. So when we look at this tool and we look at the rework cost for the two cavities, total about 41 hours. So that's like a week's worth of machine shop time. And the cost in the shop in the US would be about $4,870. That's quite a lot compared to a $27,000 mold. And what these reworks entail, we would have to wire EDM out the areas that are in red, make room to actually insert steel in there and to recut the new radiuses and the wall thicknesses on the tabs. And if you look at it, there's also areas that are shut off around side core slides that are in the mold. So it'd be very intricate machining and fitting and grinding to get this done. So I'm going to go back over to our revised part. So with that change of our part design, we did the change within SOLIDWORKS All we had to do is go in, make another configuration of our part. We can actually activate the configurations with this duplicate study. So once I set my first study and saw I needed to make a part change, I could duplicate the study. When I do that, I can name my configuration, make my part geometry changes, remesh the model to capture the new geometry, and then rerun the analysis right there. And I don't lose any of the previous analysis results or anything, so I can keep clicking back and forth to check between them. So in this case, let's look at our sync marks on this part model now. Remember, we were at 0.127, now we're at 0.057. So we cut it down from approximately 5/1000ths of an inch to around 2,000. So it cut down quite a bit. So this is something, if we would have run the analysis prior to having this mold built, we would have saved that cost of change. When I'm a part designer, let's run the analysis during the part design phase, and I can see that these walls are too thick in this area. It's gonna we're gonna have sink marks in these visual areas, and it's not going to look good. Some of the other things, since I ran the packing phase is in Plastics Professional. There's a couple of other things that we could have looked at, volumetric shrinkage or density of end of packing. I can turn on a clamping plane, and I can pull that into an area where it's thicker. And this is the area where we were having the sink marks before. And you can look at, in the prior model, we could have looked at this and seen that the density in that area is a whole lot less than the rest of the model, or a whole lot less than the standard density of the material. So that's another thing you can look at during the packing phase. So if you were to go in and increase our packing and holding time, you can see the difference in the density, and you can also look at volumetric shrinkage in areas too. But since we're concentrating on the sink marks, trying to fix the sink marks, we were able to do that with changing our part design. Here's our corrected part. Like I said, the sink mark was changed from 0.127 down to 0.057. If we look at some other options, some other things that we have within SOLIDWORKS Plastics. In SOLIDWORKS Plastics Professional, since this was a 2-cavity mold, I can run a multi-cavity analysis. So I did the multi-cavity analysis on there, but if you look at, I have my runner system cut in half, and I have specified that there's a symmetry face on my model. So what this does is allow me to run the analysis on the 2-cavity, but I only have to capture the mesh and the geometry and all of that for one side of the mold. It still calculates everything through all the formulas, and allows it to calculate your cycle times and all of that based on 2 cavities. So when you start analyzing cycle times, it's definitely better to have your runner system modeled in or simulated with the sketch lines, and then that will allow you to get more accurate cycle time prediction. If you don't have the runner system in there, you don't get the pressure drops through the runner system, and you also don't analyze for the cooling of the runner system to a point where the runner can actually be ejected too. Typically you concentrate on your part cooling time when you're trying to optimize your cycles. So if we look at the result from the multi-cavity analysis, just another slide. So if we look at the pressure in the end of fill, it actually gives us the full pressure drop and the full pressure going through the runner system. So when we look at cooling on a plastic part, definitely one of the most important things in plastic simulation is your cooling analysis. Without running a cooling analysis, the system assumes that your mold wall temperature is constant. Once you start adding cooling lines in there, you'll actually see hot spots show up in your mold. It definitely will help you in the mold design phase. So if you run a cooling analysis in Plastics Premium, it's going to identify your hotspots. You can change your sketch paths in the cooling lines. You can have 3D modeled cooling lines, or you can just have sketch lines, and then when you go through the domain assignment, you can tell it that these are cooling channels. So you're able just to go in and pick the sketch lines that are your cooling channels. You can use 3D sketches or 2D sketches and select these, set the sizes of them. You can set if they're bubblers or actually if they're baffles. So I've got these actually set up as baffles, and it allows you to analyze your cooling line. So if we're looking at the cost on this project, our cooling analysis is done after the initial mold design, but prior to cutting the steel. So we're validating our mold design. It'd be a really huge cost saving to see that there was this hot spot in the mold around this core that we could possibly improve the cooling there, which would also improve our cooling time on our part model, which is going to reduce our cycle time. So one of the things that I looked at when I ran this project, I decided to actually turn on my costing tool that's inside of SOLIDWORKS Professional. It doesn't have anything to do with the plastic simulation package. If you have SOLIDWORKS Professional, you have the costing tool, but they actually have an injection molding cost in there where you can go in and set up, as I did, if it was a cold runner mold. I put in my cycle time. So my initial cycle time on this part model, I set, and then I made my changes to my cooling time. I also made my changes to the part design and took the difference in those cycle times. So it shows me my comparison this way. So I'm able to go in and tell it how many number of parts, what waste, what my cycle time is, input the shop rates and my material costs, and it will give me those calculations. So it gives me an easy comparison, and I can actually lock that baseline in, and so any change I make comes up there. So if you want to learn more about the costing tool, I'm actually going to do a blog page on it that we'll post on our website on the costing tool for the injection molding costs. So if we look at our results comparing study 1 versus study 2, my study 1 was with the sink with added packing to try to get rid of that sink mark, which it did not work. So we look at our filling time or cooling time, my overall cycle times, so 28.6 seconds versus 25.6. So I've got 3 seconds difference in cycle time. I was able to decrease my cooling time on my part by a second or so, and the other difference is the additional packing time and packing phase that I added. Very little difference in part mass when we're packed out, but that difference is where those sink marks were. So I have an estimated part cost of 29 cents versus the 27-cent part cost. So when we look at the return on investment for SOLIDWORKS Plastics Standard, our list price with subs is just under $6,500. Our cost to rework that mold was $4,870. And then if we look at the 40 hours of lost time in the tool shop and equate that to injection molding shop, typically you're running 24 hours a day. So you have, if we look at just 5 days a week, that's 120 hours of lost production time, which equals about 33,000 parts. And you're losing your part margin. If you have a 40% markup, you're losing about $6,000 in that 1 week of lost time. So you add that cost to rework and your lost margin, you're well over the $6,400 that it cost you. So you're looking at like a $4,400 return right off the bat. So almost a 68% return on investment just on one project. So imagine doing that with several projects. On top of that, we can look at our part cost savings. Remember, we calculated 2 cents a part each just on cycle improvements by analyzing the water cooling lines, and optimizing our cycle time some before we even get to the machine. So you're looking at $2,000 over a 100,000 part run. This is going to end my webinar. I'd like to give a special thank you to Tech Tooling, who provided my tooling quote and my rework costing for me. Simon Boys over there is a really knowledgeable guy. If you want some tooling quotes or anything, take a snapshot of this. And as my SOLIDWORKS part files came from the mold design using SOLIDWORKS out of that training manual, if you haven't taken that class, it's a really nice class on creating mold core and cavity splits. Please watch our GoEngineer YouTube channel for recorded webinars such as this one and many more how-tos, tips, and tricks. Once again, this is Jeff Lendermon with GoEngineer. Thank you for taking the time today to attend this webinar,